helping you with Acorn and RISC OS computing.
Okay, yeah, so some of you may remember I did a previous talk on Python, I think it was a couple of years ago, year and a half ago, it's not that. So really just an update, sort of, what I've been doing and what's happening next. So I'll continue. So nothing like being prepared, and indeed I am nothing like being prepared. But there we go. And as a few little quotes say, yes, it's just in time. The slides were done just in time. I finished them a little bit earlier. So, if anybody got any questions, you can shout out as we go. I'll try and keep an eye on anything in the chat as well. Don't know if it tells me or not if anybody chats, but you can always unmute yourself and say something. So we're gonna have a bit of winging it, and the observer might say, yes, he's just being great. He's just being a great tit. There we go. So where are we with Python at the moment? This is sort of where we were, where we've got to from a few years ago. So we've got Python 3 version 3.8, which is the one you can get from Pacman. I think 3.10 is sort of trialed, but 3.8 is the sort of standard one. There's pip, so you can install at least a subset of packages. Pip is the Python package installer. I've got what it stands for now, I should know. That lets you install all sorts of stuff off the internet for your Python installation. Someone's got some moving furniture by the sound of it. It works pretty well. The main thing it's lacking is anything that needs to be compiled. That's really because it's pretty hard to get GCC on RISC OS to compile anything that's not set up in the way it expects. Oh, I've got a chat. What's this? Oh, someone's saying good evening. Good evening. And there is Pygame as well, and I think someone has actually ported or written some games with it. There's, I think someone's done the coding the classics stuff. I've seen, I think it's available from somewhere. So yeah, that's the SDL based thing for basically making games easier to write. So you can write fairly good games in it. The standard test one was a Space Invaders type thing, but yeah, that's been ported, and that's sort of what was done for the previous release. There's been a few bug fixes since, but not nothing too drastic. So. Back install of Python, yeah, thank you. And it was all that. I didn't remember if it was that or something like pip installs Python, because people do like their recursive acronyms, don't they? So I'll go on. So yeah, what next? So Python 3.8 is now kind of a bit falling off the edge of support. It probably has fallen off the edge of support. So it's probably time to do a new version. I have sort of tried to keep up to date, but I've never actually managed to release anything past some betas. Python 3.11, I think, is the current one. So I'm guessing it'll be, you might as well jump to the one after that, because that'll be in release candidate stage soon, or at least pre-release candidate stage. The beta stage is soon. So. The speed I work, it'll probably be out by the time I actually get around to it. With the new Python, there'll be an upgraded version of pip. I think that was the sort of where we got to with 3.10. Was Python 3.10 was fine, but the pip version of pip that we had was too old. So, and it was a case of hadn't got around to updating on the varying bits. It's been a sort of a long-standing thing that would be useful to support VFP. Most machines have it. Most vaguely modern machines have it. So it makes sense to use that, especially for anything that needs floating point, I guess. So yeah, that's on the list. I keep kind of looking at it, but it's not quite straightforward, because you kind of got to build everything for VFP or everything not for VFP. So the other, I guess, kind of thing that's been going around my mind for a while, we do need to support is standalone applications, and there's a little bit more on that just after this slide. And having been doing set development fairly recently, I think throwback support will be useful for anybody who's coded anything on RISC OS. The throwback system is really pretty helpful. That if you compile something with at least the WROCC compiler, I think GCC got as well. If you get any errors, you can double click a window and it'll take you to the error. Would be nice to try and integrate some of that with the Python error reporting. Obviously, if you've not got the source file, you can't do anything. But if you have the source file, which, if you're developing it, that would be useful. And finally, your idea here, if anybody's got any ideas or anything that's, would be useful, that's always welcome. So challenges with Python. Yeah, having several, because at the moment it can just get, here's the error, but the error may not be where you think it is. It's further levels back, so that might be a useful suggestion. Everything assumes that files are file.extension. So if you're trying to find Python files, it always searches for thing.py and is our pass available? Okay, I'll make a list of note of these on. So I think that's probably been the biggest thing that's kind of caused things not to just work under RISC OS. Unix lib does a pretty good job of supporting quite a bit of the stuff that Python expects, but often varying amounts of scripts will kind of go, I want to find the Python files in this directory, so I'll list the directory, enumerate the directory and find anything that ends in .py, which doesn't work. So you get nothing. You can, it might be /py if you've got, the standard RISC OS mappings, but then things don't look for that because everything is file.extension, which is a bit of a niggle. But most of the time it's just kind of going through it, but it's a bit of a manual process. It probably would be nice to try and help a bit of support for that. Not quite sure how to do it. It's very hard to do because you don't know if the thing you're searching for, if the file name is actually meant to be swapped around or is it actually right. Lots and lots of edge cases that meant thus far I've just not tried to do anything clever because it's too likely to go wrong in a really subtle and annoying way that's worse than not trying to be clever. Compiled extensions, which I sort of mentioned earlier. Python extensions, you can either have stuff which is just pure Python, which generally works. Aside from the previous statement about things assuming file.extension. But some extensions, there are a bit of Python and a bit of C code that needs to be compiled. So as soon as you get into the compiled stuff, it all goes a bit horribly complicated, not least because GCC, which is what you have to compile it with, will assume things need to be in a certain directory structure. So, the thing that thing.c is the file would be thing/c if you just unpacked the zip on RISC OS, but GC would expect that to be c.thing because it swaps them, it puts the C files in the C directory and the H files in the H directory and stuff like that. So that's it's probably possible to do some sort of magic, shuffle the files around, but it's one of those things you can do it manually, but try and do it programmatically. There's a bit more thinking about. There is a lack of process control, which quite a few things sort of expect. There's no real way of kicking off another process and watching what it's doing, which I think, sort of threading and stuff like that, which doesn't really have. There is the task runner module, which I did for the previous version, which at least gives you some ability to spawn another process by basically running it in another task window, which actually is now a bug fixed for PyPFS, means that might get around some of the issues with that as well. It's used quite a bit in the build process for certain things where it'll kind of spawn off a C compiler to build something, but you now need to know when it's finished and get the output, things like that. So And I guess the other big challenge is developer hours. Much like pretty much any RISC OS project, there's very limited amount of time for development, with people having jobs and work and life and such things like that. So all gets in the way. So I'm going to go back to standalone applications. So there's always a trade-off, this sort of side between the size of what you're distributing and requiring stuff to be installed. So there's in one extreme, you can just distribute a Python script, a bit of a help file that says to run this, you'll need to install these packages and get this version of Python and all that sort of stuff. Which is quite a manual process for the end user. It's probably going to put people off, unless you're okay with installing stuff. That's quite an in-depth thing to do. And the other extreme is you can just supply a box with everything installed, and there's nothing to install. Just plug it in and run. But that's not an easy way of distributing software, apart from in sort of niche cases. So obviously, this isn't a unusual problem, and it has been solved on other platforms. There are varying ways of doing it. Freezing is a common one, where it builds it all into one executable. But RISC OS, being RISC OS, is sort of different from all the others in some way. In some senses, I think it might be easier. Some senses it'll be harder. Probably the main difference is I can't see it being easy to just get it to compile everything into one program. It might be possible, but there's been a whole set of this is a case again where it kind of needs to shell out to the compiler and build stuff, but then you need the Python source code and everything installed. So the goal really is to have a Pling application that you can just download and run. How far on that path we can get is it's a target. You might need things to install from Pacman, or you can get them elsewhere. Definitely things like the libraries, which we tend to need. This is a little picture from the Python docs on its packaging for applications. It's kind of each layer, each layer in the circle gets, as you go out, gets more and more inclusive. So you're supplying more stuff. So on the inside, the PX is just the libraries. There's the ecosystem. Freezers is when you build Python. Images, you include the system libraries. Containers, virtual machines, we can't really do. RISC OS doesn't really do VMs. Or hardware. Yeah, hardware is obviously the other extreme. Here's a Raspberry Pi, everything's installed on it. Just plug it in and go. I think really RISC OS applications, we're looking at kind of levels two or three, around level 3, I think, is certainly a realistic start point. But that's kind of one of the goals that I still have for Python, is to make it easy to develop stuff and sort of saying, you can develop stuff, but then if you can't distribute it, it's works on my machine isn't very useful. It's a very useful thing. So yeah, I can write stuff, but it's all very nice on my computer, but no one else can run it. So that's not really very useful for anybody else. So yeah, the initial focus will be around the kind of depend on Python, bring the rest. I think initially I'm probably going to be focusing on, you would have to go to Pacman and install Python and the system libraries that needs. You would install that, and then you would download your other application you want to run, and it would, as long as it's seen Python in filer terms, or as long as filer has seen Python, it should then just run. It would bring all the libraries it needs with it. So you've not got to get the user to pip install stuff and make sure it's set up properly. The way Pacman works, you could distribute stuff through that with a dependency on Python. So you download, you install your application, it will then download Python if you've already got it installed. So that would at least make it sort of a fairly easy route for the end user to download your program and run it. Freezing or providing a copy of Python wouldn't you'd try to avoid that step. But there are issues around shared libraries, GCC and later uses shared libraries. Python obviously is built with that. Generally, they're installed from Pacman. Pacman doesn't like anybody else touching its stuff. It gets quite upset if you go and change anything or install something that it doesn't expect. It's fair enough. It thinks it's in charge. And yeah, I'm not sure whether interactive with the shared libraries. Anybody who's used IRIS has probably come across the sort of issues of this. That if it all works fine, it's happy, but you can get into a state where IRIS won't run because something else is using the shared libraries that IRIS now needs to update. So I think IRIS comes with its own set of libraries and its own shared library manager, so it can get. I definitely had an issue where I couldn't run Python and Iris at the same time at one point. I think it's okay now. So there are those sort of interactions that as we start using shared libraries for things, it's probably going to be an issue. Yeah. So that's gonna. We can't really just say, "Oh, don't use shared libraries," because the way when Python uses C code, it has to load as a shared library, so you can't just build it all into a massive executable. There are going to have to be some of these sort of shared library issues. I don't think they're insurmountable. It's just something we need to keep an eye on, watch out for. Certainly, if everything's done via Pacman, hopefully it'll keep everything nice and up to date for you. So moving on, so the toolbox library is probably the thing I've been most of my time working on, which is it's been a long process, I'm first to admit. So this is basically desktop development in Python, using the toolbox. So yeah, using the toolbox, we're doing lots event-driven programming. So the program's flow is really determined by user actions. I cribbed these definitions out of Wikipedia, the font of all knowledge. User actions. This is user action will be the main one. It's a desktop application, and the main loop really just listens for events and triggers callback functions. So, and as you'd expect, it's mostly used in graphical interfaces, which is exactly what we have here. I guess it's known as a version of control. So in traditional programming, like you might write in BASIC, a single tasking type program, you start at the top, you just go through each line. You could possibly call into libraries to do something, but it's all just done in the order of the program. But it's a version of control, which is what event-driven programming is effectively. The framework, you kind of hand control to the framework, and it just calls you back and says, "This has happened. What do you want to do?" So it's a different way of working, but obviously you can't control the order. As a programmer, you can't know what order the user is going to click boxes on. So it's kind of you have to go that way around. So yes, can you install just a library? You probably could, but Toolbox has got its own set of requirements, and I kind of started the other end. I started, well, how can I get the toolbox to work? And then the library kind of came after, really. If you don't know what the toolbox is, it's a graphical user interface thing. It was launched, I can't remember when now, somebody will probably tell me. It was launched sort of slightly around the RISC PC era, slightly before. I know it was a real pain on an ACE5000 because you had no memory left once you loaded the thing, because it loaded a bunch of modules, which took a big chunk of your RMA. You only had 4 megs to start with. You now lost several hundred kilobytes of a precious 4 megabytes to the toolbox, which I think didn't do it many favors. It put quite a lot of people off because the memory requirements. But yeah, used for the basic building blocks. And as you can see in the picture, it seemed to have 2 bugs built in on the wall at the front, which I realised. Not sure if that was intentional by who drew the picture. And much like templates and everything else, the UI design, the file that defines what your UI is going to look like, and the actual code of two separate systems, two separate things. So yeah, it's been updated a bit over the years. I think there's a bounty at the moment to try and merge in some of the changes from another branch. So there's still work going on with it. I think a few people have made extra components as well, extra objects. But yeah, the basic ones are, Windows menus, like that. So they're defining a resource file, which I think you can create with RESZ. Yeah, so each thing, so window, menu, whatever, are known as objects, and the things on the objects are known as components. So not everything really has, I guess, components, but the obvious one are gadgets on a window. So if you have a window, all the buttons on it, all the writable fields, all the pop-ups, stuff like that are all components, and items in a menu. So if you've got a menu, each item in that menu is a component. So each object can have a parent and an ancestor. So the parent's obviously one above where you are. The ancestor it's the one that's defined as the ancestor. It's normally like the parent window, but you can have other intervening points. So it's like the very top level. So yeah, that's sort of known as the top. And you can have multiple instances of the same class. So you can have the same window open twice, and you have it's a different object, but it's of the same window. So yeah, multiple windows basically. That's fairly standard stuff. It's or at least it was on RISC OS anyway. Having multiple windows open was like a thing. At the time, certain other operating systems didn't seem to let you do that very well. Mentioning no names. So yeah, that's the toolbox. If anybody's any programmed with it, there are varying libraries there's definitely a basic library. Obviously, there's the standard C library. I think there's a C++ one as well. I can't remember. It's supplied. The toolbox is supplied as a set of modules that are effectively language agnostic, and there are sort of wrappers for varying languages that will let you talk to it. TVX C++, yeah, that rings a bell. Must admit, I've not really done much in C++ on RISC OS. The last time I tried, it was in the C front days, and it was appalling, so I gave up. GCC is now a lot better. Yeah, okay, so the poll loop, which is much like in the middle of it, much like the main part of any WIMP program, you're not quitting, you poll and you get an event back. Quit's just a flag to say, yeah, I've had enough. Next thing now, so you call poll. These slides slightly more general than anybody who actually printed programming. You just call WIMP poll, and you get something back. So what's an event? It's really a notification something's happened, buttons pressed, menus open, windows opened, menu selected, any number of things. There's ones for pointer entering window, leaving window, user type something. There's a whole bunch of them. So it'll have some sort of identifier, some sort of number. In this say what sort of thing it is, and it's usually got a bit of data associated with it. Not always. Some things don't really have any data, at least explicitly. But normally it's like if a button's been pressed, you need to know what button's been pressed. If a pointer's entered a window, you need to know which window, things like that. So, and in RISC OS, because everything's basically done as through SWI interfaces, and it's all pretty low level in that sense. The data is a C structure, C style structure. It's a bunch of words in order. The first word means this, second word means that, the third word is a pointer to the string. That sort of level. So there's a really useful thing in Python called C types, which is one of the standard bits of the Python library, which lets you effectively use a bit of memory as a C structure and let Python access it with names. So you're not trying to say, I want the word at offset 14, and I want the string pointer at offset 24. This could actually give them nice names, and it's easy to easier to manage than trying to, if anybody's done it in BASIC, at least without the help of libraries, you're doing like block % exclamation mark 14. It's just it's lots of magic numbers effectively. You have to kind of then look up what's there, what's offset 8. So it lets you do that. And so the toolbox framework will tell you the object and component that the event relates to. So anything that comes to the toolbox, you'll know what object, what component is generating the event. So some of the actual events don't have any more data than that, because if a window's been opened, well, you know the window because it's the object. So if the window's been closed, same thing. So some of them they don't have any more data, but they do have that sort of implicit data that you always get. So I've got an example event. So this is all part of the new toolbox library stuff. So it's actually, although this is actually a WIMP event. This is an event you would get delivered when a mouse has been clicked somewhere. Is it over 2 pages? Yeah, it's just 1 page. I've probably picked this one because it fits on a slide. So you can see there, there's the fields which are actually the data of the event. So basically saying the mouse has been clicked, you get to know where the mouse is, which is the mouse field, the buttons, or which button or buttons has been pressed. I'm not sure you can press 2 buttons at once. I guess if one button's already down, maybe it would more than one. There's the window and the icon that's been clicked in. Because this is a WIMP event rather than a toolbox event, you kind of get the window and icon handles that the WIMP would give you. If anybody's done sort of WIMP programming, that's just one of the events you get from WIMP poll. I can't remember the number. Someone will no doubt pointed out in the chat what the WIMP poll number is for mouse click. But that's the event. Now the event, the class mouse click, she's defined as event. The event and C-type structure, the base classes. The C-type structure lets you do this underscore fields equals thing, and that basically means that you can map this onto a block of memory, and you can just pick those bits of information out of it. So the thing you get back from the WIMP, you can copy into one of these, and then there you go. There's your data. It's all ready for you. So you're not trying to pick apart WIMP messages. And I think the previous version of the toolbox library I did a while ago had quite a lot of manual sort of picking things apart and. Oh, I need to get, this is this field, this is this field. So this makes it simplifies it, and it's just a bit clearer what's in the data. So having got an event, you need to decide what to do with it, or who should deal with it. Whose event is it anyway? Popular TV show. So you've got an event, what to do with it. The first thing is who needs to deal with it. So it can be one of several effectively layers. In coding terms, I guess it could be the object itself can deal with it, the parent object can deal with it, the ancestor object can deal with it. If there is one, there may not be one. Obviously, if you're the top level, you won't have a parent, you won't have an ancestor if you are the ancestor. The application could deal with it, which is sort of a standard, application-wide things. Or nothing. It could be an event that no one handles it, it just gets ignored. The way these sort of things only work is you'll offer it to each of those in that order. So the thing most specific can handle it first. So if the object can handle this particular click or something, then it will do so. If it doesn't, if the parent can handle it, it will do so. If it doesn't, and the ancestor can handle it, then the application's generally for sort of global things, like if you're shutting the system down, there's a message that goes along with that you could handle application level. Just say, oh, okay, we're shutting down, I better save everything. So that's the event. That's the event ordering, and obviously the framework doesn't know how to handle the event. That's it can pass it to you, but you need to know what to do with it. Now, obviously, you could have a big switch statement for all your possible events, but that's going to get very messy very quickly. when you have then a switch on every possible event. Yeah, it would look a bit like that, and then it would just go on and on and on. You'd have one massive file with one function to handle everything. Take it to the extreme. That's what would happen. You can at least use switch in Python now since 3.8. So moving on from that one. So the other option is you can have these sort of on functions where each object can have an on type function for each event. The do nothing default would just basically would just ignore it, and you could then override those with your own implementations if you needed to. So that's I think that was kind of the way the previous toolbox library did it. There are a few issues with that, really. So yeah, that's the library. That's in the library, and that's in your code. So you would write on mouse click, make the button go green or something. You do end up with a lot of do nothing default implementations. It's what I found when I was doing this. With the smaller things, it's not so bad, but when you get like Windows, there's a whole lot of, if the user does this, and there's going to be a default of do nothing, because if they click and you've got no handlers, it'll expect to call a function that needs to be there. And you can only really handle functions you know about at the time you write the library, so it's harder to extend. That was the way the previous library worked, which it wasn't too bad, but I did have these limitations, and I kind of felt I should do, must be a better way, effectively, which is where these decorators come in, which is how the library does it, and how the new library does it now. So the idea of this is to sort of reduce the boilerplate code, so it's less to write, certainly less for the application author to write, and it puts the event handler and the event itself sort of together. So you're explicitly saying this function is a handler for this event. So I've done the almost simplest possible event handler here, which is the quit handler. So it's saying the quit event, you just call toolbox.quit, and that's all you have to do. So yeah, it's like a one-liner. But the sort of advantage of this is that it's the function can be called whatever you like. It's kind of up to you. That's free for the application writer to decide what they want to call a function. It's not got to be called on quit event or anything like that. And it's got this at toolbox handler. It just says it's the toolbox handler, and quit.quit is the event. I think it's the quit dialogues quit event. I think that's where that comes from. So it's that's how it works. So anybody's done any Python, they might have come across decorators. They're basically functions that modify other functions, which is a concept when you're not used to functions being first order objects. It's slightly confusing. But the decorator, it takes the function. So I get back one. Oh. I know there should be really, shouldn't there? Painters, yeah. They probably need all the colours as well. Can't decorate it without the right colours. So this toolbox handler decorator. Toolbox handler is actually just a function. It's one of the parameters it takes is the event, and it also then takes the function. It then wraps the function, the quit function. So in this case, the slightly tricky bit is the functions that we are modifying here. So these handler functions that operate are attached to the class. So they are class level, but I'll read my own notes now. So yeah, they're the functions at the class level, but the events will happen at the object level. So the instance level. So there's a bit of magic that needs to go around, but we'll get to that in a sec, I guess. So the class level. So any instances of my window will have the button clicked handler that's shown there. So if you have two windows of my window, they both have the same code. but it'll operate on a different instance. So it'll be a different self in Python terms. It'll be a different Python object, but it'll be the same Python class. So you'd have two My Windows if you had two windows open. It's a slight slightly awkward thing to kind of get used to if you start with simple applications, because there is only one window and there's only one icon bar icon. There's only one of everything. And you have to kind of be aware that there may be more than one. There's nothing to have more than one window. Have more than one icon bar icon if you want. Probably against Star Guide, but you could do it. So this handler will apply to all instances of my window, but it will always be called with the appropriate instance. So that's so you'll be told which window you're working on, but it'll be the same code for all of them. So that's generally what you want. You generally want each instance of the same window to operate in the same way. So what ends up with was a lot of maps in the end, actually. Handlers are defined at class level, but they need to be handled at object level. So there are basically two sets of mappings that go on. Firstly, we map the event to the class function that's going to handle it. And then when you create the instance, so in the init function, you look at what's events your class handles and put them in a map so you know how to handle them. When you get told, here's this event, can you handle it, basically. There are effective, well, ultimately there's only one sort of event, which is the thing you get back from the WIMP, but I've subcategorized them into three things, really. There's toolbox events, which are events that, as the name might suggest, comes from the toolbox. They're things that toolbox generated. They're, object has been shown, object has been hidden, buttons been clicked in the toolbox terms. There are WIMP events, which are the lower level objects you would just get back from WIMP poll. Things like user redraw come into that category. Mouse entering window, I think is one as well. Those sort of things, and I guess the null event if you want that one. And there are WIMP messages. Obviously, WIMP messages are just a subset of WIMP events. They're using codes 17, I think, 17, 18, 19. But because they're so different, I kind of thought they probably deserve their own event type. So you can say this is a message handler, this is a toolbox handler, or a WIMP handler. Generally, for toolbox applications, you'd mostly be using toolbox handlers, but obviously if you've got a message, you want to listen to a message, RISC OS window manager message, user messages, that's the name. You'd have some message handlers as well. You can actually define these handlers for one component or any component. One component. So standard example, I guess, is a window. You can say this is a handler for button clicks on this button, or this is the handler for any button click on any button in my window. It really depends what you want to do. You might have a whole bunch of buttons that the handler's pretty much going to be the same for them all, in which case you'll just say, yeah, I'll handle all button clicks. Or you might say, actually, no, this is just a handler for this particular button. There's a bit of sort of fallback logic that if there's a handler for both the specific button you've got, so if button 3 is clicked, there's a handler for button 3, it will call that handler. If there isn't, it'll fall back to the sort of general handler. And if there's both, it'll call the more specific one first. So you could say handler for any button, so then handler for button 3. And then so any other button will call one handler and button 3 will call the other one. So you can kind of mix them that way. It can be for any one component, which is sorry, this was just said one component or any component. And you can actually handle more than one event in the same handler as well. Probably not that useful most of the time, but you may want to allow several events to be handled the same thing, same way. Trying to think of some examples, you might want to do that. It's probably less common to want to do that, but you can do it. It's why preclude it if it might be useful sometime. So yeah, but generally you would have one handler for one event, and normally for any object, sorry, any component. So that's generally the structure. There's lots of these things going on. There's a map, it's basically a handler, an event which maps to a class name, which maps to a component, or none. None's the kind of match anything handler. There's a handler function, and there's a data class or a none. We'll go on to the data classes about shortly. So yeah, that's just the maps it's built up. That's kind of an internal thing as a user of the class. You don't need to look at. You don't know about this. It's all kind of behind the scenes. And there's the decorator function. So that's the thing that at toolbox handler invokes. So it takes 3 parameters, which is the event itself and the component. If you don't specify component, defaults to none, which is the catch-all kind of anything. The way decorators work, it returns a function, which takes a function. So that gets very confusing very quickly, especially if you're not used to this way of doing things. So the decorator takes the function, which is the handler. So if you do at toolbox handler quit event, so at toolbox handler quit as the event type, this internal function decorator will be applied to handler, which is the function you're now providing. So the on quit handler. I go back enough pages. So yeah, this button clicked in this slide. It will be handler in kind of orange there. Actually, we just internally when it happens, we just set the handler it's an internal thing to just set up the maps. But, so that just calls set handler. So it's kind of a bunch of nested functions, but luckily you don't really need to deal with that. It's just does it for you. So that gets you these maps of what functions on what classes. You now need to set up the objects, which is kind of the second step. So these are the instances that will be doing the handling, and it might be a subclass. So you will probably be, if you have your own window, you'll probably have a class for the window. So I think I called my window earlier. That'll be a subclass of window. So maybe window will handle it. Maybe my window will handle it. So in a similar way, you've got events to. This is slightly simpler because it's kind of resolved a lot of the class names and stuff by now. So you end up with a map of event to component, or component could be none, to basically a list of possible handlers, and that's the list of things it will try in order to see if anybody handles the event. So yeah, I guess the final sort of part of it all is the event data. There's usually some sort of data with the event, and it's generally a block of memory. I think initially I was passing that to the handlers, but that tends to mean that everybody who handles a particular type of event needs to be able to decode it, because all you're given is a block of memory, and in there you've got to find out if the users type something, you probably get the text, but you need to then decode the block of memory and fish out the text. So it makes more sense to kind of do that once. Initially, I think the previous version had this sort of concept of decoders, that you could register a decoder, say, when this event happens, here's how you pick apart its data. But I found that sort of worked okay, but there was a disconnect between the code that was handling the event and the code that was decoding it. So if the decoder hadn't been set up, you wouldn't always know, so you wouldn't get what you expected back. So I kind of, it's probably an idea that it had merits, but it didn't really scale very well. So I had to think of another way of doing it. Hence this thing, which is a toolbox event, so event data class. So this is the print event from the print dialog box. As you can see there, it gives you, there are 4 numbers that come with it. I guess there'll be offsets. I can't remember. Where there'll be some offset into the the WIMP poll block. So yeah, there are just four numbers. So we just give them names, and in Python terms, there's also these property things, which means you can ask it little bits about this. Again, I've picked this one because it nicely fits on a slide. So because this is actually a print event, it's a toolbox event. The toolbox event provides some of these fields itself, which you can't see here. So self.flags is actually defined in the toolbox event, because all toolbox events have the flags word. And the way the print dialog box works is it uses flags. See 1 and 2 there, bits 1 and 2, or 0 and 1, I guess. Bit 0 is to say if it's sideways or not. I don't know why they call it sideways instead of landscape, but that's what they did. Bit 1 is to say if it's draft mode. So they're just two flags that we're sort of picking apart here. So this class really is it's an event that's it's the data part of it's really showing you the data of the print event. Yeah, start page, end page, number of copies, and the scale factor. So that's just the data. That's sort of picking apart the data that you get from the structure. But instead of picking apart, we just take the structure and feed it to a C types. Because toolbox event is a C type structure, print event is also a C type structure. Hence, you can just underscore fields underscore, which is a bit of C types magic, really. Just says these are the fields. And there's a bit more code there, I guess. This is kind of how the event dispatch works, in slightly more known if you've done RISC OS programming terms. You call WIMP poll, you look at the reason. If the reason code is toolbox event, there is a bit of magic to handle auto created and object auto created and deleted, because they maintain internal dictionaries of objects that we currently have. Otherwise, it just goes through to a toolbox dispatcher, which gives it the event code, the ID block, which is the toolbox 6-word structure, I think, with a self, parent, an ancestor, object, and component, which just really tells you what the event relates to. So you just call the dispatcher, which I think is elsewhere. I've tried not going too much nitty-gritty detail. As a user of the library, most of this stuff's all kind of hidden, really. But the other bit of stuff that came out, I guess, was one of the things that the hyperviewer needed to do was user redraw. Anybody who's done user redraw probably fairly familiar with it. You basically tell the WIMP that this window needs your help. The application needs to help redraw it, and then the WIMP, every time it needs something redrawn, it will call you and say, "Hey, I need this window redrawn." You then go through a loop of asking it which bits need redrawing. You redraw them, ask it again. Eventually, it says, "I've done." So it's a fairly common pattern for anything that's anything that's sort of graphics, anything more than standard buttons, writable fields, radio buttons, all those sort of things are sort of, you don't need it, but once you start drawing things on the screen, you kind of end up doing a bit of user redraw usually. But the viewer also has a printable thing, so you can print it. There's a print option, and I thought these things are going to be fairly common, but you're not always going to want them. So if you had a window that was just a configuration application type thing, you wouldn't really want user redraw. You wouldn't want to print it probably. So to have that stuff there, what you didn't need, seemed a bit unnecessary. You can't easily put them in an inheritance tree because there's no obvious tree structure. It is just things that you kind of may or may not need. So, this one I needed a user reader on a print thing. There's no ordering of those. You can have one without the other. So you can have multiple mix-ins. It's kind of a Python thing, I guess. So having a tree doesn't really work. So yeah, so I decided to use this mixins approach, and I don't know if he's on here, but thanks to Charles for his suggestion of these, where it came from. So yeah, so the hypertext viewer is a user redraw thing, user redraw mixin and a print mixin. It's also a window because it is a window. So let's move on from that. So there's an example. So this is the user redraw mixin. It's a WIMP handler because it needs to handle the WIMP redraw. The redraw function is a WIMP handler for the redraw message. And this is really how this is kind of the standard bit of code that you would have to do. If you didn't have a mixin or it done in the library, you have to repeat this for every possible case. So you'd have this sort of chunk of code end up copying pasted into each window that needed redrawing. What it does is it has this redraw data structure, which it sets up and then calls the WIMP. It's sort of outside the toolbox here a little bit. You kind of fall back to just using WIMP calls and WIMP commands. So you get the visible area, scroll bars in the redraw area. That's how it works. See, so yeah, so there's a bit more of it here. So you call WIMP redraw window. It tells you if there's any more data. If there is, you figure out what's redrawing. There's a self.redraw window in the middle of this slide. I've got a pointer to a mouse, but you can't see a mouse is, so not very useful. What can you? There's a self-redraw window in there, which is the application code. So that's a callback to the application code. So if you have a mixin, you do have to provide a function that matches the redraw window thing there in orangey color. But that's all you have to do. So the mixin will just talk to the WIMP for you and then call you to say, redraw this bit. Oh, okay, yeah, bye. I'm never sure if the mouse appears on presentations, but yeah, it's the middle line of that function, really. So instead of having to do this kind of call the redraw loop yourself and keep checking it and doing all these calculations, you just, the mixer will do it for you, and you just then say, yeah, call me with these parameters there. So obviously you'll need to know the visible area, the scroll bars, the redraw area, whereabouts you're doing it. So that's what you need to drill. That's what you need to know to do the redrawing. So you just have to provide that function, which makes your code, as an application writer, your code is just what you have to do rather than scaffolding and calling the WIMP to do stuff for you. I think that's makes quite a neat solution, really. And you don't have to have all this stuff if you don't need it. So you just pick the mixins that you want rather than having all this baked into the window class, and it just makes it more code and more to deal with. Okay, let's go on. So Hyper, which was anybody who remembers the toolbox when it came out, it came with a few really, really simple examples, like something with a window and a window with a button, and then a hypercard system. There was like nothing in the middle. Obviously, the hyper thing, which it's called, was designed to. It was really designed, I think, by Acorn as a demo to do stuff with Toolbox. I do wonder if they partly used it as a way of finding bugs in Toolbox as well. It was, it came with the Toolbox as a big example. Look what you can do with our Toolbox. It's really easy to do stuff. So that's what they came with. So I decided to use this. I brought this to Python version, and it did actually prove a really useful test bed. So I guess in a way it's possibly what it was originally designed for as well. It's just a way of testing stuff. Not sure that's a very useful application really, but so we can have a look at the code. Now, can I share it? I'll just stop sharing. Can I try share a different window? Share screen, yeah, and see. Right, we should have a RISC OS window. Can we see a RISC OS window? You can, good. It's always a start. I also see the sheer mess of my computer now because I've not tidied anything up. So So I should have done this first, shouldn't I? But I ended up turning my machine on late. So yeah, I guess the two things to show here are not there. Bear with me a moment while I just find what I'm trying to get to. I got all good professional demos. Everything's not where you want it to be at the time, is it? It's called Hyper, or did I call it something else? Here it is, Hyper. Apologies. So this is the inside of the Hyper application. What you'd say is then the boot files, help files, run files. The C and H aren't compiled or anything. I just had them there as a reference because this is what I was converting. So I shall load the run image. The run image is probably longer than it should be. It probably should be split up a bit. But like anything it starts off quite small and you just keep adding to it, and eventually it sort of just gets bigger and bigger. So the only bit I've really split out is the code to read the hypercard files, which are sort of vaguely binary things. Yeah, there's sort of a text thing like that. Sorry, yes, they're not binary; they're a script thing. So that's kind of been split out. But yeah, so there's a bunch of imports. There's any sort of Python thing with a whole bunch of imports there. Sort of importing each object that we need. So we got a menu, windows, the scale. There's a scale button. So there's a supply scale factor event that comes from that. So yeah, there's a whole bunch of things there. We need a couple of mix-ins. There's a data transfer mix-in, which handles data open mixing, which is the data open message, which is basically the message that gets sent around when you double click a file to see if anybody can open it. So there's basically a whole bunch of imports of what we need. There's R events, which we define there, which it's fair. There's just basically a bunch of event numbers and definitions that we care about. So these are some of the classes and their handlers. So this is the icon bar menu. This first I did run it, couldn't I? Yeah, so that's the hypercard. You can click on these things; they'll go to different cards. So you can go back. You can click another one. It's got this weird pointer. It's kind of you can't see the pointer on VNC, but it's kind of inverted pointer. You can click on these things. They just give you these are basically just draw files. Each needs a draw file, and how it works is it will just loads the draw files and renders it. Hence why it's a user redrawn window. Yeah, you can click around these things. You can go home, which takes you to the top. You can go back. It runs more levels. Yeah, Hyper. There's a calculator as well actually. But yeah, Hyper was a bit more interesting. There's this status thing. You can turn the status window off. No, you can't because it's got a bug in it. I will ignore that. See, live demos always work well. I have been working on it. That's why. So that's basically the toolbox application. Good information there. So it's got all the standard things. You can quit it. I go to Spears. And yeah, this was provided with the C++ compiler version 5, which came with the toolbox came with that. So there's a couple of, so that's the menu here. So this is the icon bar menu. This sort of template thing, which is really a link between the class, the C class, or sorry, the Python class, and the name in the res file. I bet I've got res scene. I knew that would happen. Development. Just bear with me again. DDE one. Resed in here, I think. I can't find Resed now, of course. The time I need it. It's in here, isn't it? Yeah, one of this there. So there's Resed. So this template line in the code matches the template in here, which is the iBar menu, which is this thing. And there's the menu. It's got 4 items. So in toolbox terms, this is the menu is the object, and the info, show stack, delete stack, and quit are the components. Right, you can see it there. That's component 1. That's component 0. That's component 2. That's component 3. They're not even in order. But, there we go. Quit's component 0. Info's component 1. Oh, my VNC is just. Oh, it's happy now. So that's the information about those. So that's what this. That's what this is a class for those menus. It's probably only going to be one, but it would handle any number of them. In fact, they're the magic numbers from the file, the entries for those extra menu items. So there's a handler for a menu about to be shown, which is a fairly most of the toolbox objects have an event say they're about to be shown. Which in this case, these two items, show stack and delete stack. If there are no stacks, they grey out, and that's what this bit of code does. It goes through it. I think yeah. So it fades them out if there's no views. Then we'll then find the views menu. So if there are views, of course, I'll just close the view I had, which was yeah, it was running. You can tell I've been fiddling with this lately because it's not quite as. So this menu needs to be created as well. So when you pop up the hyper menu, it will then create the menu for the views for show stack and delete stack. It's the same number of entries. So that second bit of code does goes through and builds that up. So it's the views menu. There is a bit of kind of magic around here, I guess. The views menu is this thing, which is by default empty because it just has to be built on the fly. There's then another handler for the view event, which is actually on this menu. So when you click on this menu, it will call this handler. So again, we're slightly into, this is a case where the top menu handler, which is this hyper menu, handles the events for the view because this menu is just a list of views. So you also need to know if you did show or delete. So that's what this kind of thing does. So if you click show, it will go find it and show it. If you click delete, it will hide it and delete it from the list. And finally, if you delete one, it also has to kind of handle the case that if that was the last one, we need to grey things out again. So that's sort of the handler. So that's the code that just handles this menu, these two menu items anyway, this menu system. Info is handled elsewhere because that's handled on this box being shown, and quit's just handled. It calls it that quit event, which just calls quit. So that's fairly straightforward. The viewer is probably the more complicated bit. Again, that's this kind of sort of setup. You can create a viewer, you load a file. The display method really just sets the card to sets the new card and processes it. So each of these cards has got an identity. I think it starts at like card 0 or something like that. When you click on one, it will then load another card, and each card is a draw file, I think. Yeah, so here's all the draw files, all on with draw files. So at the top, there you go, there's the cover. Oh, yeah, this literally is the cover, isn't it? So there's the top. That's the top. That's what you're looking at when you start with. Each in the file, the HTML file that goes with it, each block, you can define blocks of area on the screen that when you click on them will go to different cards. That's basically all it does. Each card's a draw file. So when you click it, then load a new draw file, move on. So yeah, there's a little bit of a kind of more low level than I'd like to be at the moment. Code in here to kind of fiddle around with creating the buttons, because obviously each you need a button to click on, so or an area to click on. So that's kind of done in there. That handles that. There is this toolbar which you can turn off. No, you can't, because that's the bug I had earlier. Yeah, you should be able to turn it off. Yeah, load it again. Yeah, so that's the handling of all that lot, and there's a refresh which just forces it to redraw itself. This is an example of the user redraw mixin. So this is the, let's highlight it. That's all the code you kind of have to write to do user redraw. You'll be called by the mixin with this. This function will be called with the appropriate parameters. What we do here is we create a transformation matrix and basically pass everything to draw file render with the draw file we want to draw and say, here you go, draw it. Here's where I want it drawn. There's this little bit in the middle, these two lines, we just set the background color just by calling limp set color and basically doing CLG as if it's in basic. So that's literally what we have to do for the redraw. So you're not trying to do all that redraw loop handling. That's all done for you. You just call with a, here's what you have to do. So you know, a fairly straightforward one. So there's a menu on here, which again is on the same thing. So when you call, there's a view menu, which is this one. When this is shown, we can grey out or ungray the print option, depending if we've got a printer driver loaded. This is what this does. So if the printer's there, we can grey. If I load printers, it should ungray. Let's try it. Live demos. What could go wrong? There you go. See now it's print. Now this handler will now say, oh yeah, printer driver's there. You can print things. Again, the file info, there's a file info box, which is this thing. The box itself is a standard toolbox window. When it's shown, it just fills in the details for you. There's a scale menu, or the scale view, this thing here, which again, the scale view is a standard toolbox thing. You can define what these buttons do. So I can put it at the front, there you go. So all this window is done by the toolbox for you. You just have to handle what happens when the user picks a scale, which is handled here. Again, these are all defined on this window, which is the viewer window, because actually defining them here doesn't really help you much, because you need to know, you'll know they've pressed the scale value, but you don't know what the scaling. You know, if you have another window open, which one is it? So I think initially I ended up with all these things being handled at the lower level, but then I found that actually I was just doing a lot of cases of pass it back up to the parent class and say, okay, they've scaled it 75%, do what you need to do. So in this case, it's just all that does when you apply the scale. So all it does, it sets the scale value to be whatever the user's picked and changes the window extent, so it now fits. Shows the window again, so it redraws it. Draws it in the right size. This display self card really just picks draws the same card again, and then refreshes the window. So when you change the scale, it all updates nicely. Go back to 100%. There you go. Obviously, if you scale down, it makes the window smaller. And then when you scale back up again, the window stays the same size, so it doesn't just jump and be really annoying. So you have to kind of rescale it. So yeah, there's a status handler, which I can't show you because it doesn't work. All that. So yeah, if that's so that's to show and hide this status bar, which is in toolbox terms a toolbar. It's called a toolbar, and you can have 4 of them. You can have one inside and outside bottom, bottom left and top left or something like that. So you can have one sort of, where Artworks has its toolbars, and one where this is, and one you can have one outside the window as well. So if you want to be able to use all the window space. Yeah, so then there's home handlers, which are each of these buttons, these two buttons rather, will deliver specific events, which have been defined as the home and back buttons. Home just clears the history and displays the top level. Back just takes one off the history and displays that. Unless the history is empty when it goes to the top. So if you do previous loads of times, you don't crash it by running out of places to go. Yes, the other. So these are toolbox handlers. So on toolbox events, this one's a mouse. It's a WIMP handler because it's the mouse clicked WIMP event. But you still get the toolbox ID block filled in, so you can figure out what button's been clicked. What that does is it actually finds out what that button. Yeah, the buttons you can't see because they're kind of buttons without a border, but they just use as areas you can click on. So that will, when you click on a button, it will append the current card to the history. So when you go back, you get to where you are now, and displays the next card that you've picked on. So that already handles this clicking about. Any further? Go further from some of them and others. Libraries. So yeah, some of these are. So your tools, you can kind of go to tools and then to link, and then you can go previous, take your tools. Obviously, home takes you to the top. If you do previous and the top, there's nowhere else to go. Finally, I think for this one, there's the print mix-in, which handles the printing. Let's risk it. So that's the print dialog box, number of copies, the scale, which round to go. Let's see if we can make a PDF. Again. There you go, prints out. It's done it in black and white, but fair enough. That's the probably the option I have on the printer. Anyway, so that's how it does the printing. So there's a couple of functions that the print mixin will expect you to provide. One is to declare the fonts. I think is not all print drivers will ask for it, but PostScript ones do, which is what the PDF driver does. You then asks you again to declare give the rectangles, which is to say what bits you want printed, and then it calls you very similar to the user redraw loop and just says, yeah, fill in this rectangle for me, or print this rectangle for me. Again, it just calls that. So this is the thing it'll probably call you. It calls you once and says, what do you want me to print? This one, it just says, yeah, print this, and just keeps calling that till it's all done. So again, it just really, the idea is to make the amount of code that the application writer has to provide as small as possible, rather than having to deal with the scaffolding yourself of handling the print loop and stuff like that. So it's finally, there's the application, which is at a different level again. So these are at the toolbox. These two things, viewer, where's it going? That's viewer. Yeah, that's obviously operating at that's a window. Oh, this is a window. It's that window there, in fact. So it's operating at the toolbox object level. Application operates a bit higher than that. So it's probably got the actual init function, which actually sets everything up. So when you call applications in it will set up the toolbox for you. There's the quit handler, which just basically tells toolbox quit, which calls it to drop out of the poll loop. It's about to be shown on the prog info dialog, which is this thing here. When this opens up, it fills in the version number from the messages file. So that's just done every time you open that, it fills that in for you. And there's the data open mix-in, which handles loading of files. If it's not FAC, which is the type of the hypertext file, it just ignores it. Otherwise, it creates a view. one thing these handlers do, you can see it here more clearly. If they return false, it will pass it on to the next potential handler. So if you have several handlers that it could apply to, it will pass it on. If it doesn't return false, it will consider it handled. I use that phrase carefully. If it doesn't return false, so if it returns true or it doesn't return, if it returns none, which is the standard, if you just drop out at the bottom of the function with no return, it'll return none. If you return none, it's assumed to handle it. And that's really a decision I kind of made because most of the time your handler will handle it. It's kind of, you've written a handler, you probably are going to handle the thing you've been given. So the common case is you'll just return. It just stops lots of return trues everywhere, which is what I found I ended up with. And this function just called to create the view. It creates a new view viewer. It shows it on the screen, loads the file, displays the initial card. And then the main, if you're running it, which is basically what happens in run. Sorry, run image. When you run the run image, it will create the app. If you pass any files in the command line, which will happen if it's not running, the WIMP will send the message around. Does everybody know how to handle this? No. So it looks at the alias run type for the file, which is FAC. Then just call this to load it. So it will create the views for you, and then it just says app run. The app run is really just pass over to control to toolbox, or to the toolbox library, and which then calls WIMP poll for you to churn through the messages. So those are very whistle-stop tour of the toolbox application, which is mostly working. There's a few subtle bugs there. And I have a shortcut for this, but I've had to reduce my screen resolution to fit onto so you can see it through Zoom. And of course, the shortcut's about there. Screen. Never mind. So the RISC OS toolbox code itself, it's quite split up from the previous version. There's one file per object, one file per mixin. So this ones I've created so far. So there's the user reader or mixin. It's none of them particularly big. There's save as one as well, which handles the save as protocol. So if you have something that can be save as, you could use that one. I'm guessing the idea is, these would kind of expand a bit over time as we find more of them. There's a file for each gadget. They're the ones I've done so far, which oddly enough map pretty much exactly to the ones we need for the hypertext viewer. The objects, again, there's pretty more of those. Things like the scale object. You can find out varying things about it. You can set the values, set the title, and they generally have this event. So there's an event with a little bit of data. So it's an apply factor event, which has got the factor just as an integer. And because it's a toolbox event, also gets its type on here. This is probably, the event is probably the biggest block of code. The toolbox event is an event, and it's a C-type, one of these C-type structures. So anything that's a subclass of toolbox event will get these size, reference, number, event code, and flags, which is where the print thing will get its sideways or not flag from. When you do this fields thing here, because this is the toolbox event is the parent class. It will fill those in, then it will add these. It'll actually append these to the end, which makes it quite neat because you can just kind of build them up rather than having to define them each time. So I'll now stop sharing that. Share my PowerPoint again. So just sort of moving on a little bit to the sort of thoughts about it. This library has been a work of several iterations of, that's not quite right. It's taken quite a long time. Probably more time than I thought it was going to take. I did have several, oh, it'll be this, and it's like, no, it doesn't quite handle this properly. But I think it is now a sort of a state I'm happy with it in. I think the decorators was the right thing to do, but it was a bit tricky to get right. Yeah, that was quite tricky to get them to work properly. But I think it was worth persevering with to get that sort of flexibility. And big thank you to Charles for the mixing suggestions, which really allow you to define these common bits of code that you may want, but not forcing things that you may not want. So that was a nice little level of control of how much you use, how much you need, I guess. Another slide of this. The toolbox added a bit of complexities to the library. Just the way it worked. There's obviously the data blocks, the multiple event types that made it just not quite a standard off-the-shelf event dispatch system. So otherwise, I could have just used one, I guess. But I think one of the key things I sort of set out for this was to reduce the boilerplate code which you needed to write. So really trying to make writing an application as easy as possible for anybody who's either not written applications RISC OS or not written them for a long time, or not written them in Python, or not written the toolbox. So I think that's pretty much been achieved. There's a little stat there. The really rough and ready figures, because I just kind of ran it all through count and line counter thing. But the Python version of Hyper is about 400 lines, and the C code is about 1800 for roughly the same output. Possibly I've not implemented everything, but it's quite a lot shorter, quite a lot smaller to do. So I'm going to ask if any questions now, since it's 9 o'clock. I've been wittering on for a long time. Anybody got any questions? Deadly silence. Everyone's gone to sleep.
There's always a stunned silence when this happens.
Stop sharing. Is anything on the chat? No, good. Nothing already answered. Is there anything anybody else wants to sort of have a look at? Are we okay? Can't quite tell who's here now.
It's quite interesting seeing what you showed was really interesting. I've only recently started doing Python programming away from RISC OS or at all, but the event style way of writing an application is something that we've been doing for a while with the library that we inherited when we took over the impact application from the previous developer.
Oh, of course, yeah, because you've taken on that, haven't you, from I can't remember it before, yeah.
And that obviously in C you can use function pointers and all kinds of things like that. Before we took on that application, I had no idea about this kind of way of writing a program. So we were writing things in C pretty much the way you'd write them in BASIC, and with all those horrible long switch statements, and this, that, and the other, and functions that tried to handle the mouse for tons of different windows. And it's quite unmanageable when your application gets bigger.
Yeah, it's sort of one of these things that works okay for a small application or a small thing, and then but I think you just kind of add to it, and so it's not. And then before you know it, it's like there's this massive switch statement here, and it's not working quite right, and I can't figure out which of these paths it's going through.
And it's also very much harder to divide your application up into separate source files so that you're not scrolling up and down millions of lines.
Yeah.
So seeing that you've produced something like this for Python is really excellent, because I couldn't really imagine doing WIMP application programming in any other style now. Everything we've written more recently, and when I say more recently, I'm talking about the last 12 years.
That is recent, surely.
has been has been in this style. So it's great to see something like this for Python, because I think I'd have been looking around for that if I wanted to do anything in Python on RISC OS. I suppose the question is, I mean, you've done a few mix-ins for some of these things that you've needed, and obviously people can write their own mix-ins for stuff that that you haven't provided, I guess. But in terms of the rest of the library supporting the toolbox itself, I mean, do you feel it's basically kind of pretty much finished and ready to be unleashed on the world?
Yeah, pretty much. Obviously, there's a few rough edges I want to kind of smooth off a bit. There are a few gaps in the object and component classes that I need to fill in. I have been working with, I think Charles is on here, but Charles Ferguson, to try and automate some of that, at least as a first stab, so I'm not just sitting there transcribing stuff from C. I think once that's done, it probably is ready to be unleashed on the world. It's taken quite a long time to get this far, and there's always this temptation to go, oh, I'll just add this bit in, I'll just add this bit in, I'll just add this bit in. But at some point, you kind of got to call it and say, yeah, it's good enough. We can do another version later if we need to. But otherwise, it's never going to be finished, right?
Yes.
So yeah, I think I'd want to support all the standard toolbox things that are around. So whatever the C library supports, basically, is my aim. I know there are some stuff that's come on since then, but I'm going to ignore those for now. I cover my ears and pretend they don't exist, at least for this version. They can come later. In terms of mix-ins, I need to have a look at what. It's anything that's kind of got this pattern of, it's kind of a bit of boilerplate code that you need to churn through, and then you fill in this bit. I mean, that's. I kind of want to do anything that's particularly obvious, but not going to go overboard. Again, it's one of these things where I think I'm getting to the point now where it's more important to get it out and get people to use it. If there's a demand for another few mix-ins, they can just be added, and we'll just 1.01, 1.02 versions. It's more useful to get something out there that people can use. And if it's can we have a mix-in for the, I don't know, they say, well, there already is one for saving, but for something else, then it's just going to be add it, up the version number, and then go from there. I think, rather than trying to sit down now and kind of go through every possible, well, do we need a mix-in for this? Need a mix-in for that? So I'll probably do a first pass of anything obvious, and then just go from there and say, well, anything else will. It's a lot easier now to add things to libraries and redistribute them.
I liked the way you were thinking about how to allow people to release standalone applications, and I think it certainly would be an awful lot easier if people were installing stuff via Pacman, because you could then pull in your toolbox library and pull in whatever things that were dependent. That's clearly, if people can be persuaded to package stuff up for Pacman, it would simplify that immensely. And if they needed a more recent version of the library with these mix-ins, you just have to up that requirement, and it would pull it in automatically.
It gets it automatically, whereas otherwise it's just like, the best you can do is a text file of install this and install this, and the users are like, I can't bother with that.
Yeah.
It's too much effort, or either it's too much effort, or honestly, I don't know how to do it. So, and it's just, you're reducing your reach of your application if you start doing that more than, I think you probably do have to say, well, if you can, you might need to use Pacman to get it, or at least to get Python. And again, I was sort of saying earlier, it'd be lovely if you could just download a thing you just drag onto your hard drive and run, but that's probably too much of a jump, at least initially. So having it, if you can get it from Pacman, and Pacman will get all the dependencies for you, that's probably a good step. So the shared libraries, I may have to have a look at for that, but that's. It's so that's I guess my next real goal, apart from keeping fairly up to date with Python. Obviously, I don't have the time, energy, resources to like every new Python version, but I think it's been a couple of years ish, so it's probably due. So I'm probably just going to do this thing. I'll just skip a few versions and then say, oh well, we'll just take the next one as a port, because it's otherwise you're trying to maintain too many spinning wheels in one go. There's not really a lot of time to do it. So 3.8's been fine for as long as it's been out, pretty much. I did find a bug the other day, but I think so I'll just it makes sense just to skip now to the latest or the upcoming latest, I think, and then just get some more support for longer. It's things change fairly quickly, and you just need to. You can't be totally on top of them, but if you can, more worried about not falling behind, I think, more than trying to be right at the bleeding edge all the time. So you're doing jumps, don't you? It's like, well, we're a bit behind now, we'll jump up. If you start trailing too far, it becomes too big a jump then to do the next one. So I did have 3.10 working at one point, but running the Python interpreter itself was fine, but it was all the support stuff around it that takes the effort sometimes. So.
Chris, I've just got a comment about Python with Iris. I can't get them to work together. I'll give you a quick demonstration. If I share my screen, that's not working. I'll unshare that screen. Share that screen.
Oh, there we go. That's something.
Can you see something, Sean? I've got about 10 screens here. It's a Mac. I've got about. I need to scroll along until I find. Right, can you see a RISC OS screen?
I can now. Yeah.
Excellent. Wow. Right now. Okay. This is my Python page. I've got about. Those are my screens basically, and Python's down in the bottom left-hand corner. And this one is the simplest program. Print hello, and here it is. And if I run Go, well, I'll show you what Go contains. Nothing very much there. It just says Python 3, and it runs Ola Pi.
Yeah.
With standard out, standard out, and standard out. Okay. So if I run that, we should, if it works, we should get standard out, and there it is, P out, and it contains Ola Mundo, which is what you'd expect to get
from that.
From that bit of Python there, print Ola. Okay, that all works well. Now, if I close those two, I'll delete the out file. So we're back to scratch. If I run it again, it will work again. But I'm now going to run Iris, which is up the top here somewhere. On this screen, I open Iris, which is the latest Iris, and I run Iris. And there it is, and it's ARMX6, which isn't true. There's Iris working.
Okay, yeah, so our Iris is up and running.
Okay, now if I go back to Python down here, bottom left, and I run this again, you probably can't read that, but it says apps development Python 3 bin Python 3.8 can't load library libdl1.so.
Yeah, I think this is a shared libraries thing.
Yeah, I think that's so. As far as I know, I've got the latest Iris and I've got Python's up to date, and they don't work together, which is not really a problem because
John, it's the same problem with Lua. It's the same problem with everything that has been compiled with the previous RISC OS shared lib, and when you run Iris, it kills the SO manager and loads it again. But yeah. By the way, there is help from Andrew in the chat.
okay. Copy the shared libs into Iris shared libs.
I think because Iris kind of has its own set of libs, doesn't it? That it kind of brings along. From what I remember, I know I had it working at some point, but it doesn't work on this machine now. So. And that's my fault for not chasing it up. Really.
It's 310. Okay. Right, I've read that. So I'm not really bothered because I don't run Iris on the ARM X6 anyway, because it's a bit too slow. So I don't really have a problem with it. I'm not all that keen on copying the shared libs about, really.
I think it's partly because Iris needs a newer set of libraries, doesn't it?
Yeah. So if it changes the path to the shared libs, right, to the one that is in Iris, that's also what Andrew is saying. Obviously, right. when you reload Python, it tries to load this is shared lib, which are not in the distribution of the shared lib with Iris, so I cannot find them. So one way is you install, or you copy actually the Python required shared lib into the Iris shared lib, which I agree with Matthew when he says it's a bit odd solution. It is. So we should use just one shared lib. That's why they are shared or shared, whatever it's pronounced.
Yeah.
That's the whole point, being shared. But I think that because Iris is using something, and Andrew, correct me if I'm wrong.
Can I jump in to answer?
Sure.
Yeah. So basically, the problem here is that Iris is using, or has historically been using, versions of SO Manager, Army ABI support, and various other modules that are essentially beta test and may or may not cause the computers to crash or otherwise fail when you're using shared libraries that are older. And rather than, I mean, we could have taken the approach and just forced everybody to put SO Manager, latest versions, Army ABI, all the latest versions onto the system, and be damned. You know, if you want Iris, then tough luck. You've got to update your system, and if that knackers all your other software, tough luck. That's how it is. I don't like that kind of philosophy because I think forcing people to install beta software just to run the web browsers is, you know, that's not a good, that seems wrong if it then causes them other problems. So what I decided to do was to keep the Iris shared libs inside Iris until we're satisfied that everything is sort of release version, and make sure that when you run Iris, it uses the shared libs that is applied inside Iris to operate. And this is okay because for a lot of the time, because there aren't very many applications that use shared libraries, so not a problem. But of course, with, as you say, Lua and Python are the two ones that spring to mind that do. There probably are others, but they don't immediately come to mind. Now, we could ship Iris with all the Python and Lua libraries pre-installed, which would solve the problem, but make the Iris download considerably larger and require me to do even more checking. Or we could leave it as an exercise for the user if they are actively running Python and Lua, which is probably in reality only a small proportion of users, which is kind of how I've left it at the moment. Now I know that's not ideal, but that's kind of the boat we're in. There are users who have just merged the Iris shared libs with the master shared libs, and they claim that there are now no issues in doing that. But the person who told me that then in the next paragraph in his email said, but I want to report this, and this system instability when running Iris, which I couldn't then reproduce on my machine. So I'm still skeptical that
I know.
This is the problem. So it's the trade-off between polluting somebody's perfectly working existing system with beta Iris stuff versus having to combine them together.
Yeah, and Andrew, I'm perfectly happy with that situation. I just raised it because Chris said he thought that Iris and Python would coexist now, and I just wanted to clarify that it still wasn't the case. That was all. I'm certainly pretty happy with the ARMX6 not running Iris because it's not a lot of point. I've got other things where I can run Iris.
I mean, honestly, I probably need to have an offline chat with Chris to find out exactly what libraries we need to include and make sure that Iris is including them. And then,
yeah, that's probably.
Sure. I know I did something like this to get on when we did RISC OS Direct. It was an absolute pig getting Python 2, Python 3, and Otter browser to all coexist at the time. That's taking Iris out of the equation altogether. And still to this day, you could get two of them to work together. You could get any two of them to work together, but not necessarily all three. Some of them, if you ran, the order in which you ran them was significant. That Python 3 would run fine if it was the first thing you ran, and Python 2 would run fine. But if you ran Python 3 after running Python 2, Python 3 would then blow up. And it was stuff like this, and I don't have a magic bullet to solve that yet, and would appreciate people who are perhaps spending more time with the shared library system.
There is another way, Andrew. The shared library supports symlink, so instead of fattening with the executable, it is eventually possible to create symlink that still load the DLL from the original place, and that regardless if you have changed the default path. I don't know if I'm making sense, because obviously symlinks is not something that is native RISC OS, but it works with the shared lib.
This is something that might be a solution to investigate. Last time I checked, I couldn't figure out how to manually create those symlinks.
It's just a file with a link inside. That's all it is. It's
just a text file, isn't it? With the text is the.
I thought there was a bit more to it. Maybe I'm misremembering. It's a long time, but I thought it was like.
We can write a quick utility.
Or I thought there was more to it than just a pointer. But if I'm wrong, then that's great.
Yeah. No, they're just pointers. So we can write a quick utility, even in BBC Basic. If there is some extra byte in there, we can just add it.
I think it's got link, as in the text link, and then some bytes. But effectively, it's mainly just a.
It's very simple. If you can try that, you can even write a script that just takes all the libraries that you don't have, just to maintain some compatibility with the existing system and avoid obviously mixing things up. And because they are all symlink, you can control them.
Yeah. Well, I think that's something that possibly we take offline as to how best to implement something like that.
It's worth a try.
Yeah, because I guess it would be Python and Lua and other things, but they're the two I can think of as well.
I think Otter browser was the tricky one to. As I say, I remember with Direct, I had 3 or 4 to try and get to work together, and it was.
Yeah, there is starting to be quite a bit more now, because there is also the FFmpeg app that seems to be using the shared libs for the. I don't remember now the name of the app. I'm sorry, because I don't use it. But there is an application to process MPEGs that is using shared libs. Everything that uses core, although if there is only NetSurf that uses core, but I think they use a local copy. I may be wrong. I need to double check. Yeah, everything that uses URL core lib that'll probably fetch it from the shared libs.
I mean, the other approach that occurred to me was that we might be able to do something with path variables, but my recollection is that a lot of the paths are set by the shared object manager module when it loads. It doesn't load in the most.
Yeah, and that's what's causing the problem in the first place, right? Because it redefines the default path for the shared lib, so to the directory that you have it in, and therefore it no longer sees the other shared libs that are Python, Lua, and all these things.
Yeah, as I say, I mean, in theory, you could do star set. You know, a path can have more than one location in it.
Yeah,
but I think that gets overridden by the SO manager module when it loads, if I remember rightly.
Yeah,
because the SO manager and stuff and path and variables don't get set in the run file as you might expect. It just sets an alias for a file type, and then the shared object manager gets loaded by the alias for the file type or something like that.
Yes, the whole shared libs is a bit between double quote a bit Nazi, because even when you try to update it, you cannot install your shared lib in shared lib, because the moment Pacman updates shared lib itself, it will remove all your stuff. It's the whole thing is a bit wobbly.
Yeah, but I found before that Pacman really doesn't like you doing anything behind its back. It's like, no, you're not doing that.
Yeah. No, I had to write a lot of trigger code to make it actually behave correctly.
I go back to what I was saying. I'm sure my gut tells me we need an equivalent to Plink sysmerge, but
yes,
for shared objects, I've been asking people to write that for a while, but I did not found the right person.
No, but yes, and it
needs to integrate with Pacman 100%, but also allow third-party applications to be bundled with a shared libs update if necessary.
Yeah, because we kind of need to be able to update shared libs some places outside. Really, it's like if you need the shared libs, you need to be able to provide the ones you need without.
Well, certainly, if you're going to use it for commercial software, you would want to be able to do that, because you can't rely on the shared libs being downloaded off Pacman for a commercial application.
Yeah. No, but it's something that.
Sorry to get carried away, but I just thought it was worth explaining why I do what I do in Iris.
No, it makes sense. I mean,
no, it's not the best. It's one of these ones. Whatever you do, you can't please everybody all of the time, unfortunately.
You can. I mean, if you want, have a look at the way my DME and Launchpad get installed via Pacman, because it does a lot of things that Pacman cannot do, and the package itself has something called triggers that it do all the installation of all the bits in the right places, because Pacman cannot install DME. Has a lot of limitations. And by the way, it even boots the Launchpad automatically after installation. So there is a lot that can be done. But for policies, I'm not really sure. Because actually, package managers on Linux, which is where Pacman come from, right? They can do already all these things. So I don't understand why on RISC OS is so restrictive. But and package managers, they install on Linux, they install each library has its own package, and then they all get installed in USR lib and lib64, which are the containers for all the shared libraries on Linux. It's the same for Windows, by the way. So that fact that shared lib it's a single package with all the libs. It's a RISC OS thing only. It's nonsensical in terms of software.
It doesn't really make sense, does it? Because the things in it come from a disparate set of places.
It's nonsensical. I don't know why they did that. I think at the beginning it was the usual thing, RISC OS, right? At the beginning there was just one guy doing it, so he just started to put all the libs into a package, and then it became some kind of process. I don't know. And now all the libs are in a single package. All the DLL. It's just, yeah.
It's quite easy to get from the first to the second, though. because you just, you've only got one library, so it's okay. And it's only one more, so it's okay. And then it's suddenly there's 50 files in here, and it's like, oh, what do I do now?
We don't have I didn't think about that. That's the the historical answer. So in the case of the shared lib, I mean, I talk about like somebody that actually works on Linux and all these things. It's a mistake the way we are handling it on RISC OS. Now I know that Linux isn't perfect. That is not about being perfect, Andrew. This is about being pragmatic. The way the shared libs are handled on RISC OS is wrong, because it implies that if you create a new shared libs, then you have to give it to the person that is packaging shared libs. So, and as Andrew Ramsey said correctly, that's not going to happen with commercial application for sure. So, the way Linux and Windows, by the way, and Mac OS, they all do handle, it's different and it's pragmatic, it's logical.
Yeah, the other sort of wrinkle for Python is that the bits of Python that are compiled in C but imported into Python end up being shared libraries, because that's how it does the imports. So they need to be found on the path and all that sort of stuff as well, which is why it's hard to do anything that how to get, it's why pip won't install anything that needs compiling, because it doesn't know how to compile it, and it's too different from Linux just to run the Linux or the Unix command. So straight Python's easy enough. You just copy files into the right place, and it'll probably pick them up. But building stuff's another level of things like Pygame and NumPy. Though NumPy doesn't work, I kind of manually crank it. I think I ended up building it on Linux and getting the compiled script and running it through GCC again.
Okay, so I guess there's no chance of getting TK-Inter working then.
So I hadn't realised that the packaging of the shared libraries in Pacman and so on was so broken. I mean, I've only recently started using Pacman for setting up new machines, because it just turns out to be so much easier to get things updated that way. Once you've got too many machines in the house, you've got to find some way of automatically keeping them up to date. There's a whole list of things in there that are called lib this and lib that. Sorry, John, there's a lot of noise coming from you when you're not muted. I don't know what it is, but anyway. Yes, I assumed that they were all libraries that were going shared libs, but looking at it, I see quite a few of them are actually dev packages, which are presumably all the header files.
They are static lib. So the lib that you see in Pacman, these are static libraries. They all get installed in apps library, and if you install just one of them and have a look, go in apps library, you will see that they are the /a, which it's Linux, by the way. The /a for static libraries. So we have a lot of stuff that we're borrowing from Linux.
There's another factor just to make it even muddier, and that is that over time, the locations, the files within shared, if you look inside shared libs and go one layer down, I think it's something like sharedlibs.libs or something like that. The files that exist in there have changed over time as GCC developers have changed their minds as to how they want to structure it. So I noticed that what's distributed now as the default set of libraries in shared libs is not the same as it was in terms of structure.
That has happened when they introduced the EABI, right?
I think so. Certainly, I noticed that what I got on my ARMX6 from sort of, let's say, 8 years ago was differently structured to how it is now if you download a fresh copy with Pacman. So even structurally, it's fluid and what have you. So I'm not even 100% sure as to exactly what much of the sort of standard C and C++ shared libraries should be inside
Yeah, so
the
it's
top directory versus being further down the tree within shared libs.libs. Now, whether older applications expect things to be in different places compared to where they were originally, which is a whole part of why it requires a certain amount of carefully picking apart and deciding what's needed based on really probably involving the people who are at the GCC end as well as people like myself and Chris and yourself.
Yeah, I mean, so yeah, I mean, the two biggest problem we have right now with Pacman is nothing to do. I mean, Pacman is fantastic. I love it. But there are two major problems. One is the fact that it's only WIMP. So if my app wants to pull down dependency that are dynamic, that are not package related, but they are an extension related, that becomes problematic because you don't have a command line that you can run from an obey file to pull down the dependencies. So the user has to open Pacman and do it. That's the first problem. The second problem is the way we are handling shared lib, which can be solved because actually Pacman can, I mean, I am handling components that in my DME that are separated from the core, and they get installed inside the core, and the core gets updated correctly. But Pacman does cause problems with this thing, so I had to kind of create my own backend there. Pacman doesn't handle it well, so that it does have issues. It's not as mature as APT or YAM are on Linux or so on and so forth. I'm not really sure because, as you mentioned, this is part of the problem is the way we organize shared lib, which is the GCC guys. But there are also problems on Pacman itself, which is Alan was responsible for that, and it also has to handle things using the RPKG library. So Pacman is just a front end, but it's the RPKG library that kind of imposes certain behaviors, I think. So there is these three elements.
Yeah.
It sounds like it just needs a bit of a, like you say, a bit of a careful think about how to solve it. It's just going to be a careful think and not just add another layer of issues to the current onion. This is just going to get nowhere forward. I think each component can probably do most of what it needs to do. It's just getting them together and handling the edge cases. It is an odd case for Pacman to be importing. To be handling things that can change outside of it. It's not really what it was designed for doing. But... Cheerio.
Good, Matthew. So yeah, I mean, it is solvable. It's not impossible to solve. It's nothing to do with RISC OS. It has to do just with people that should probably talk to each other and reorganize things a little bit. Like if Pacman cannot handle a sub path as a separate entity, then put the libraries outside of shared lib application. Just create lib like we have on Linux, so everybody can install their libraries in there, right? Outside, and then Pacman can update shared lib code easily, and we can all add our own SO into lib without having problems, and that's there. That's probably the easiest way to do this, and the same will be for Iris. Just add his own things in there. And if they can use also subdirectory inside lib, that's even better, because at that point, Iris will have his own subdirectory and can specify his path, right? Subpath. So
Right, folks, I'm going to stop recording now, but that doesn't mean you can carry on talking, but I'm just going to stop.